I don't like turn there. All right, here we go. Stat. I'm going to try to get in and out in this lesson. Stat E, 10.1.2. Still intro to hypothesis testing. Day 2. So we know the whole premise here is we want to conduct a hypothesis test. We are going to conduct a hypothesis test. Yesterday, we did the first step in a hypothesis test. Step 1, which is doing what? What do we do for the first step in hypothesis testing? This is where we just do the hypothesis. I'm gonna shrink it down, and this is where we do the hypothesis. Now, yes, yesterday in your homework, I requested you to do P and H, which was the idea to define the parameter. And I'm still going to ask you to do that. Define the parameter. I'm going to put a little asterisk around that. And what I mean by putting an asterisk on there is that it is not a requirement for you. When it comes to your assessment, I'm not going to require you to define the parameter. Just like your exam, I did not make you define the parameter to get full credit on that, conducting a confidence interval, creating a confidence interval. However, if you're not practicing identifying and writing the parameter right now, you're going to be struggling to identify what the parameter is later on. Because in the last step of the hypothesis test, we need to restate the parameter. All right? And the last step, you're going to have to define what it is that we are trying to find and test. So after that, really the first step is to define what is the null hypothesis, HO, and what is the alternative hypothesis, HA. We know that the null hypothesis is always written as P equals some blank. That's where we write P0. And our alternative hypothesis is always P, some inequality symbol, that's not a not equal or not an or equal to symbol, also with P0. Okay? So you need as we practice in today's do now, as we took notes in yesterday's, this is all the same. I already defined all those, what the circle thing means. I already defined what P and PO, all that stuff is from yesterday's notes. So that's our first step. Just a quick review. All that is a review of yesterday. All right, so that's what you did on last night's homework. You did, I assigned 7 of them for you. I did the first 2 for you, so there was only 5 of them that you had to do really quickly. We'll talk a little bit more about those once the due date is set for those. And then we move to step 2. And step 2 is our assumptions check. Now, you've done the assumption. This is going to be the 3rd unit where you've checked assumptions and conditions. Actually, yeah, our 3rd unit that I said, and I told you the first time we were doing this, I go, you're going to have to keep doing assumptions and conditions. You're going to have to keep doing these assumption checks. We're going to talk about the normal model. We're going to keep talking about the normal model, the sampling distribution. And I said, don't overlook it. If you don't understand it, now is the time to ask those questions because it's going to hurt you on the Unit 8 exam. It's going to hurt you on the Unit 9 exam. And if you still don't know how to do it, it's going to hurt you on the Unit 10 exam. And this is where we check SIN. Part, just like in the confidence interval, when I ask you to create a confidence interval, you better have checked your conditions on that exam yesterday because that was a major portion of the grade, right? If you didn't check your assumptions and conditions and you didn't do SIN, you probably took a huge hit on your exam. Same thing will happen here when I ask you to do a hypothesis test. If you don't check the assumptions and conditions, you're going to take a big hit on the exam because it is part of doing it. Part of doing inferences, you have to first confirm that we met our assumptions such that the sampling distribution of sample proportions is approximately normal. Now we spent the whole unit 7, on sampling distributions and the normal model, 7 and 8. So that's what we need to check here. And it's the same. The first two are exactly the same. S is that the sample is random. Or can we assume it's random because there's nothing that says it's not random? All right. If they specifically tell me something that isn't random, then I have to call it out. I, which is independence. Remember I for independence, and that's that the sample size N is less than 10%, less than equal to 10%. There's no more than 10% of the population. Okay. And then we get to the last one, the new one. And I'm actually going to change the color on this one. Let's make it blue. The N is changed. Well, it is the same. Remember, this is still normality. We're still checking the normality. But we're going to do the success and failures. It's still the success and failures, but what's different here is it's expected. When we did confidence interval, it was observed successes. Because in confidence intervals, we base everything on the sample that we create. The idea is in confidence intervals, you take a sample, and based on that sample, what does the sampling distribution look like? That's not the case here. In a hypothesis test, we have not yet taken a sample or looked at the sample. Based on our null hypothesis, based on what is believed to be true, is what we look at. And so as such, this formula is N times P0 must be at least 10, and N times 1 minus P0 must be at least 10. And I know it looks very similar, but it is based on P0, not the observes. And most likely it will be a decimal. So this can be a decimal. And in reality, it will likely be a decimal. It could be an integer as well. But most likely it's going to be a decimal because in the previous one, I told you it can't be a decimal. I kept saying that because it was how many successes were found in your sample. That's not what we're seeing here. Because the idea is before we actually collect the data, before we actually look at the data, how many successes will I expect to find in my sample? How many failures will I expect to find? So slight change. It's not P hat, it's not P, because we don't even know P. We don't know what P hat is yet. And there we go. Some additional knowledge, meaning that you're not going to be doing it in your work, but some additional knowledge. When we're talking here about, of course, the sampling distribution, and the sampling distribution is based on P0, our hypothesized mean. So the mean of P hat, we're going to use P0. And the standard deviation of P hat, we're going to use the square root of P0, 1 minus P0 over N. That second formula will become a little bit more important tomorrow. The good news is I'm going to bypass you. When we did confidence intervals, you remember how I made you do the math and you had to plug in all the numbers for the confidence interval? I am not going to do that for hypothesis testing. We're going to go directly to the calculator tomorrow. Tomorrow is very calculator heavy. All right? Tomorrow is very calculator heavy. So be prepared. Tomorrow we do step 3 and step 4. Hypothesis testing has 4 steps. Confidence intervals had 3 steps, right? Check the assumptions, find the interval, interpret the interval. That's confidence intervals, 3 steps. Hypothesis testing has 4 steps. State your hypotheses, check the assumptions, and then the other 2 steps we're going to learn tomorrow. Step 3 is all calculator. All right, I could go into more detail a bit about step 3. I could spend an entire day or 2 days on step 3. I've done that in AP. Okay, because you don't always have to access to the calculator. But we're going to get through step 3 in 1 day and step 4 in 1 day tomorrow. All right, let's do an example. For the example, we're going to do the do now problem. So in the do now, which was problem 1, slide 2 from Desmos, it said something along the lines of the NCAA, in the NCAA, 2% of athletes go pro. Okay? A college believes their athletes, Desmos. I'm going to zoom in so it's a little more clear. Desmos. Their athletes go pro more often. Okay? In addition, I'm going to write in here, this is additional writing that wasn't there before, 400 recent athletes were randomly sampled and nine went pro. Okay. That's the additional information, and you didn't need that information in your do now because I didn't ask you about the assumptions and conditions. Now here's something to note. First off, I told you the observed 9 went pro. There's a problem with 9 going pro first and foremost, right? 9 is not greater than 10. Actually, let me change that. Let me actually change from 9 to 10. So here's where a lot of students make a large mistake. They look at this and they say, oh, 10 was the number of successes. So in a success and failures condition, 10 is at least 10, right? Yay. But that's wrong. You don't use the sample, the observed. In hypothesis testing, you use the expected. So as we did in our, do now, my null hypothesis is P equals 0.02, and my null hypothesis is P is greater than 0.02. Okay, so that's the hypotheses. Then we should move on to the assumptions. S-I-N. Okay. Is the S satisfied? And if so, why? Is the first assumption satisfied? I see a nod, yes. Yes. The answer is yes, it is, because the sample is, and it actually says randomly on this problem. But if it didn't say randomly, we would assume. There's nothing that said. And the other class, first period, I just said recent graduates. I didn't say the word recent, randomly selected graduates. We would assume, and we would move on to that. Unless there's something specific that tells me, whoa, this is not random at all. If they told me, for example, it was the 400 captains of their sport. Okay, that's a different, that is not random, right? All the captains were chosen, you're going to get very bad data, right? Independence. Okay, well, 400 is definitely less than 10% of all athletes at the college. Okay? There's definitely more than 400. There's 4,000. There's definitely more than 4,000 college athletes that have ever gone through the school system. Check. Then comes the new one. This is where we're going to check n times P0. Well, n is 400 and P0 is 0.02, which gives me what? What's 2 times 4? It gives me 8. Not 80. 80 would be way too much. So 8, which is less than 10. Oh no, it fails. I want to point out that in today's work, some of these may fail because I'm testing to see if you're doing them and checking them correctly. So it is possible that the condition fails. Now, even though I don't need it, I'll do it anyways. N times 1 minus P0 would be 400 times 1 minus 0.02, which would give me 392, which is greater than or equal to 10. However, I don't even need to check the second step because the first one failed. So the conditions are not met. The assumptions are not met. And when I say they're not met, what does that mean? It means that the sampling distribution is likely not going to be, or it will not, we cannot assume that the sampling distribution will be approximately normal. And so in our follow-up sets, remember, we're basing everything on the normal model, which we know the percentage breakdown of everything. And if it's not normal, then we can't do that. All right. Let's look at going back to Desmos, everybody. Bring it on back to Desmos. Now we're back on a computer. Let me open up the next slides, the first one. So, this one's a little bit different. This one says 600 athletes. 600. And it just says a random sample of 600 college athletes. Okay, so is the first condition met? Yes. Can the sample be considered independent? Is 600 less than 10% of all college athletes? Yes. Is the number of expected successes and failures sufficiently large? Okay. What is 2% of 600? 2%. That would be 1%. 12. Is 12 sufficiently large? Yes. What makes something sufficiently large? Or equal to at least 10. Being at least 10 makes it sufficiently large. All right. If 12 are successes, then are we going to have enough failures? Then 600 minus 12 is definitely going to be good. So that one passes as well. Now, in this problem, all of them passed, but like again, they're not. If you go back or go all the way to the last slide, it'll tell you, yes, on that problem, question 1. I know the numbering, I should have done the slide number. Now that I think of it, instead of question number, I should have did slide number. Too late to change. Yes. I got them all correct. I know it will. You can be like, oh, I was wrong. Let me go back and let me check my answer and change it. If you get it wrong, ask me. Ask your classmates. Why was this one wrong? Why did I say yes and it was no? Why did I say no and it was yes? Why didn't I check that? If you simply just do that and just try to move forward, same thing with the homework. If all you're doing is just copying down answers, and when it comes to the exam, you have no clue what to do. We have another exam coming up next week on this one where, yes, we have a sharp turnaround. I'm keeping this very light, this unit very light. And the reason is I need to test you for it because you need to do confidence intervals and hypothesis tests for your final project. So I'm doing 2 quick assessments and then we move into the final project, which will require you to do a confidence interval and a hypothesis test based on data that you will have. Okay?